Okay, so this is practice problem number 2, lesson number. So the lesson that we are doing is lesson number 2, right? And this is unit 3, the first problem. So in the 1990, the value of a home is 170, and since then, its value has increased 5% per year. Okay. Now, what does this mean is, like earlier, the task that we did is last time it was somewhere 10%, 15%. So here we make a table out of this. So I think the best thing is make a table. Everybody make a table like this to understand here. Okay. So that means 1990. So this is like 1990. This is 1991, 1992. Just to get a feel of what's happening, 1993. Okay, and so on. So let's write down T is number of years. Now, what is T represents is the number of years since uh, since 1990. So if you think of the year 1990, that itself is like a 0 year. So this is 0. Starts now from here to here. It is like 1 year past. So that's like 1. Then from here to 1992, 2 years from 1990, which is 2 years. Then this will be 1993 is 3 years, and so on, right? So then 4 and 5 like this. But when the house was bought, the house was 170,000. That's the cost of the when you bought the house. And the second one is value of the, let's put it like VT. Now what is VT means? So this is value of the house. This is value of the house. Value of the house. Okay. So hope I make sense. So the question was, what is the approximate value of the home in the 1993? Now, what is 1993 basically means? 3 years. This means 3 years since 1990, right? So it means if it is that means your T is so that means your T here is T is 3. What that means is what is that multiplies each time. So what is the growth factor? Because the value is growing, the home value is growing. So we need to know what is the growth factor. Well, what they gave us in the problem is 5%. So what is the meaning of 5% increase? So 5% is 5 divided by 100, which is in the decimal form, it is 0.05. So that means the growth factor, so the number that we have to multiply each time to get the next one it's not that you are multiplying 0.05, but the growth factor. So I want you to write this. This is very important. Growth factor, which later on we call it like a B, is always 1 plus this number, this percent increase, which is 0.05. And when you do that math, you get 1.05. Okay, so that means every time you're multiplying 1.05. Okay, so if you do simple math on your calculator, so let me go down and say, okay, so how do I find this answer? All you do is it is 170,000. You multiply 1.05 and you end up getting on the calculator, you will see it's like you're multiplying this thing 3 times because you want to go 1, 2, and 3. So it's like going from here to here is So from here, you multiply 1.05. So it's like 1.05 and another 1.05. So together there are three 1.505 multiply, and that's why you put the 3 up there. So this is 3. Okay. So hopefully I'm making sense. Very nice problem. How the value of the home every year, how much does it increase? And you want to see the trend happening, so that how long you want to keep your house. Maybe you want to sell if you are moving from one state to another state. So people need to know how the trend is. Okay. So now if you put this on the calculator, this piece, okay, you end up getting 196 and 7960. So that's the answer. So this answer is 196 7 9 and 6. I hope I'm making sense here. Okay. So that's the value of the. So what is the takeaway here is that you have to know whenever they say 5% increase, that's like percentage increase, which is this piece, right? But then you need to also know what's the growth factor. This is different. Growth factor actually is the 100% plus. It's like this. Whatever you already value of the home previously, that is 100% plus 5%. So that's the understanding of that 1 plus 0 point. So still I would like to write this again to make sense. Right, Brianna? Okay. So I hope, Brianna, I think you got 196, right? I remember seeing your answer there. Okay. Huh? So, and I said, okay, how did you get? What was the process? Like, what strategy did you use? And strategy is this piece, see? It's like you're multiplying 1.05, 1.05, 1.05 three times, 1, 2, and 3, right? And you get the answer. I hope some of you understood it. I mean, I'm sure many of you understood it. Okay, next is the second question is what write an equation in function notation. Now, see, this function notation means it's like f of something like this, f of x. But because we are talking about the value of the home, we can think of VT. So let me wipe this off and make it nice. Okay. So this is done. So this piece is done. So this piece is done. Okay. So this is what we are trying to figure out. Write the equation function notation. So we'll write VT, value of the home. So what does that means is value of the home T years since 1990. See, the house was bought in 1990. So the answer is, so in the task we did, remember 2.1, 2.2, 2.3, we did this. So just remember is you want to create a exponential function. So this is called, we are creating exponential function. So what it means is we are modeling a real life situation into mathematical symbol notations and using how math is used in real life. So this is exponential function. So VT in the beginning. So whatever is beginning is the A. So later on also you will use this. And then the growth factor, which is, we'll call it B, and raised to the T. So now here in this example, in the beginning, the home cost was 170,000. Okay. And then times the growth factor was 1.05 and raised to T, and you're done. See how beautiful it is. Okay. Am I making sense to all of you? Correct. So this is a beautiful exponential. I call it beautiful because I see that students don't like maths because they can't see any relevance of why are we even learning this? What the heck I got to do with this? Now look at this beautiful exponential function. We model the information into the exponential function, and you want to see the trend as what's going on. So the next question is another one. If you keep going like this, and what is the question is in 2020, what's going on? So if you see 2020, how many years since 1990 to 2020? So we want to know answer the third question. Look at the third question. Will the value of the home be more than 500,000? So in 30 years, remember most of the loans that when the house is bought, you see the loan is the maximum is like 30 years. So this is like, okay, I buy in 1990, 170,000. So with this trend, what is the value of the home in 30 years? Because until 2020, so let me go here and wipe this off. Okay, I'll make a room here for me. Okay, so let me take this also. This is done. This piece is done. Okay, so now I need to know in the year 2020, okay, and the house was bought in 1990, right? And you can see clearly if you subtract, you get 30 years. 30 years. That means your T is 30. See this? So T is 30. So, so what we have to do is we have to find the value of the home 30. So T is 30 equals. So it is 170,000. Okay, that's the value of the home in the year 1990. And now you need to multiply the scale factor. How many times do we multiply the scale factor? So this has to be multiplied by 1.05 raised to 30. So you're multiplying that 1.05 30 times. So I hope everybody is understanding and really trying to grasp this, what I'm saying, these words. Okay. Now on your calculator, if you see, let's do this I'll put it on my calculator, which I have, and see what answer did you get. Okay. So here is my calculator here. Uh, so it was 170,000, correct? So 170,000 multiply, and it is open parenthesis 1.05, close it, and then I go up and put 30. So you can put on your calculator and you want to know what's the answer. So I just enter and see this is what I get. So what does this mean? So the answer that I got is 734,730. What do you think happened? The question was asked, what is the value of the car? I mean, home here. The question was, what was the question? I forgot. Yeah. Will the house be more than 500,000? And see, now it became 734. So with that, so let me go back to that problem. So let me copy here. So this answer we got. Okay. So this is 734,730. So I'll round it to this, which is more than, which is more than 500,000. Okay, so it's more than 500,000. So I hope I made sense to you. So that was a beautiful question, and let's go to another question. I'll just pause it so that I can figure out on it. Okay. So this is the practice problem, second question. Okay. Now, if you see this question is The graph shows a wolf population which has been growing exponentially. What this means is, even though there are only 4 years given, since there are only 4 years, but if you take the whole maybe 15 years, and maybe it's something like this, this is how the trend is, how the exponential graph of the exponential function looks like. But because we are using only 4 years, somehow it looks like a line. See, it looks like a line, but it is growing. Now let's see what percent is growing. The first question you're asking is, what was the population when it was first measured? So when they first figure out, nothing is told about which year. It doesn't say that, but you can always check this out. This is where you can see 0, and it starts with this point, and clearly that point is this point is 9. The down is 80, and that is 120. So between, if I have 80 and this is 120, and you can see halfway down will be, because this is altogether 40. Okay, this is 40, so halfway down will be 100. So that's how you have to think. Hey, that's 100 here. Okay, so this is that means in the beginning. So what this basically means, if you make a simple table in the beginning, 0 is 100 like this. Okay, and this means t is number of years, and w, wolf starts with w, so wt. So we want to create also, we want to model mathematical equation for this function, for this scenario or situation. So first part is done. What was the population when it was first measured? So we got 100. So that's A part. A in the beginning is 100. Okay. Then after that you see 1. I can say 2. If you look at the graph, what if you see what this is 1 here. So what is this point? Can you see this point? So here it is. This point is 0. So this point is 0, 100. So first one. And the second point, you can clearly see this point is 1. After 1 year, you can see there is it goes exactly at 120. See? So it is 100 and 120. So that means this number is 120. Okay. So here we want to know what is the factor that multiplies. So by what factor did the population grow in the first year? And you can see I made a table. So what is that number that times here? So what number multiplies 100? It means what number multiplies 100? So this means what is that multiplies to get to 120? It is as good as dividing by this. So you get 100 like this. So that means you want to know what is this answer? That means this means it is 12 divided by 10. Okay? And you can see we can still lower this, and you see 2 dividing by 2 both sides, numerator and the denominator, gets 6/5. So which is actually, this is a fraction, but you can also write it as 1.2. So if you do simple maths there, look at this. 6 divided by 5, 5 goes 1 is 5, and you get 10, and you put a decimal, and you get 1.2. It means the growth factor, that is B, what I'm talking is each time you multiply 1.2. See, again you multiply. So every time you multiply 1.2 and you get the next one. So the goal here is what is the percent increase? We can even know now the percent increase. Look at beautiful thing happening is not just a growth factor. So you got the growth factor, this part. So this B part, the growth. So the growth factor is, even though the growth factor is 1.2, which you already seen how I got it, which is same as 1 plus 0.2, which is same as 100% plus 2 per, this 0.2 basically means 20%. See, because this is 100 over 100, which is the whole, and this is 20% is 20 over 100. So understanding the percentages, what is growth factor, what is percent increase. So here the percent increase is, so here the percent increase. So the percent increase is 20%. So the population of wolf is really growing a little faster. I would say 20% is quite a big percentage and is growing. So there are two ways you can remember. One is 1.2. So one is 1.2, which is either you can write 1.2 or you can also write it as 6. So both are correct. So you can, growth factor is 1.2 or 6/5. So that takes care of the question number B. Okay. Now, last question is write an equation relating the wolf population W and the number of years since it was started measuring, right? So how do we do this? Is like last time, remember? So I'm gonna do it right here. So maybe I'll take off this and make a room for me. So each time, can you see? So no matter how many years since the beginning, they try to measure all the total population like this. So somewhere here, when it is t years, let's see if it is t, we want to know how many times did we multiply 1.2, 1.2, 1.2, 1.2. That's what it means. So how many times? And that's the t part. So your final answer is, so WT, so that's how it is. This is the population, wolf population after t years is I will write like a formula. It is like A B raised to T. In this case, in the beginning it was 100, and then this is the B part, which is 1.2, and raised to T. This is the beautiful equation. So we created another exponential function that model the wolf population. So that's the answer. Beautiful exponential function. So 20% is the percent increase. Growth factor is 1.2. This is in the beginning. The 100 means in the beginning when it was measured how many wolf, how much is the wolf population. So that's the in the beginning. Okay. So that takes care of the three questions, beautiful question, and I hope I made sense. Let me pause. Okay. So this is problem number 3. This is problem number 3. This time you just have to look at the graph and see, hey, can you, let's put it like this. Can you create with the function notation f of x like this? See, right now, f of x is, we want to create some number has to be here times some number and raised to x. So what is this piece is, we use it like a and inside is called b. This is the beginning number, which is also the y-intercept, beginning number, okay, which is the y-intercept. So where the graph starts, it's when we have 0, x is the 0, what is the y? And you can clearly see the number right here. Look at this number. If you see this, it goes by hundreds. So this is like 100, and this piece, I will take it like 50 because that's how it looks like optics. Even though we are not 100% sure, but then you can make out it is 50. I'll tell you why. So first of all, imagine we don't know this. Okay, I'll put a question mark. I don't know. Let's put it. But we do know from the graph 2 points. When it is 1 here, look at this one. When it is 1, that's 100. Look at this. This means after 1, it is 100. And this point, which you can clearly see this piece. So So the question is, just by optics, we can't say that 50 is the answer. We want to know really why, okay? Let's see, this point at least we know it is 1 is 100, and this point is 2 is 2. When it is 2, you can see there it is. This is 200. Say. So this is 200, correct? So like if I want to make a table like this, so you can clearly see if I make a table and I say, okay, that's x and this is f of x, input, output. So 0 is, we don't know, let's put it, and 1, at least we know it is 100% 100, and 2 is 200. And these two numbers should guide us, help us to find the growth factor. So we need to know what is this B, which is growth factor. It is factor, but it is growing, so I call it growth factor like this. Okay, growth factor B. And how do we figure that out? So what multiplies? The question is what multiplies 100 to get to what number multiplies 100? So if I write 100, so what is that number which multiplies 200 to get to 200? So it's like a common sense. And all of you will say that it is 2. Okay, it is 2. But sometimes imagine if it was difficult number, then the best way is divide this like this and you get the answer. So that answer which is B here is 2. So that means growth factor is 2. So your B is 2. So the B is 2. See? So we know that B is 2. So the next one, if you want to know the next one, again you multiply 2, you get 400. See, this is 3 when it is 3. If it is 4 here, then again you multiply by 2, you get 800. See, so that's how it is. But the question here is, of course, they gave us here also, look at the graph also, you can clearly make out. I'm just finishing with this. Please hold on. Do not. Okay, so B is 2. And now if you go backwards, so this, if you go this way, you multiply 2. So that means the one before will be half of this. So this is 50. So when you go here, your B becomes 50. So your answer becomes 50 times, and B is 2. So it is 2 raised to x. How beautiful the function. So this is your final answer for the question number 3. And I hope I made sense to you. And you will continue likewise because I will continue this and also do question number 4 and 5. And then I will upload it in the YouTube so for your reference to get it. Now, question number 4 is, if you see the equation is given, is the exponential function is given, and what does this exponential function represents is it's the value of a car. So instead of giving v of t, the function notation used is ft. So it doesn't matter. So all it means is the value of the car in dollars, t years after it was purchased or bought. So the question is, what do this number represent? What does this 24 that you see in the problem, and what does this number represent? Now 24,000 that you see here, this 24,000. You can easily compare this exponential function, which is 24,000 times 0.88 raised to the power t, right? So you can compare to this ft equals a into b raised to x, where this number is the very first number is in the beginning when the car was purchased. So when the car was purchased, the cost of the car was, or 24,000 is the value of the car in dollars when it was purchased. So this is value of the car. So this is the value of the car in dollars when it was purchased. So that's what that means. It was. So I'm just saying it's easy, but I just writing here so that just to make sense of the problem. ACD. Okay. Now, what does this number represent? Now, 0.88 is a factor. So this is a factor. So let me put it right here, maybe here. So this number represents a factor. So each time you're multiplying the factor by which the value changes each year. So So this is the number by which the value changes each year. So it means if I want to make a table like this, it means when you buy the car, it's 0 in the beginning. The cost was 24,000. So if this is T and this is your FT, and each year maybe the value of the car depreciates. So that's what it means. So that means each time you're multiplying a factor. So that's the factor that you're multiplying is 0.88. Okay. Now this 0.8 basically also means I can write it as 8, 8. If you multiply and divide by 100, you get 88. So it means 88% stays. So it means it retains the 88% is the 88% value of car retains. It means stays. That means what does it mean? Also means 12%, which is actually 100% minus if you take 88%. So there is a drop. So this is a drop in drop. That means we don't say drop, we say percent decrease. So what percent is the depreciation? What percent? The 12% decrease or depreciates. Another decrease is you can say dep. Okay, so depreciates. So that means each time we multiply these, there's a drop of 12%. So 88% is what it retains. So that's what those things mean. The next question is asking what does f of 9 means? So f of 9, if you see from the equation, say the f of 9, it means in the 24,500 that you have, you multiply 0.88 raised to the power 9. That means after 9 years, the value, so it's the value of the car. So this f of 9, so this f of 9, f9 represents value of the car, I'm writing with my finger. 9 years after it was purchased. Okay, so you can fast forward this. I'm just trying to, some of the things are very easy but I like to make it very clear what each number represents. Now the last question we have to graph this. So for this, what I will do is, okay, now let's see if you want to, the third question is that you have to sketch. Now in order to sketch this, so for this to sketch, we need to know, let's say 0, 1, 2, 3, 4, 5, some years. Okay, so we'll try to figure out what was the cost value of the car. So that means we need to multiply here the first year. That means we multiply 0.88. So in the equation, so this will be, if I want to find what is the value of the car, so that means I have to use the calculator. Now if I use my calculator right here, so that means it is 24,000 and multiply by 0.88 and then raised to the power 1. Okay, I'm just trying to, so the answer becomes 21,000. I think I put the wrong entry, so let me go back here. So I'll have to go backspace, go down and enter, and then change this to 24,500, and then I enter. So you get 21,560. So I'll try to write it on my paper. So that's for this one, and I go backspace and put 2 and see what happens. So I enter, and this time let's put it 2, and I get 18,972. So let me take a note of this, and then I go back to the graph that we did. Okay, so that means your value is 24,000 was the beginning. So I'll try to use this somewhere here as 25,000. Let's see, a little higher, and you can think of multiple of 5. So I'm using multiple of 5,000, so that's like 25,000. I can break this way. So this is like 5,000. So this will be 5,000. This will be 10,000. This will be 15, and so on, right? And that's 20 and 20. So we got those numbers. Remember in the calculator, this number was 24,560, and the other one was 18,972. So we'll try to round it. The first is this point. The second one is almost like 24,000. Sorry, the first one is 24,000. Slight mistake. Just want to make sure I'm writing it. This number should be, this is 21,000 here when you multiply. So this is 21560. So that's almost like 22, and the 22 will be, so somewhere here maybe. So that's 22. So this point is right here. Next one is 18. So 18 will be somewhere here. And now you can use more and more, and maybe it is going, maybe it's like this. It's just a sketch. Okay. So this will be the graph of the sketch of this one, how the value of the car is decreasing in the exponential form. See, like this. So the whole graph like this. I hope this makes sense. And let's have two more problems and we are done. Question number 5 says you have two. So question number 5 says find the first two terms of an x. Oh, they give you the first two terms are already given. So this is how it is. So the first two terms are given 0, 1, 2, and 3, and 4. So this is 18 and this is 6. So you have to figure out the next three terms. So if this is input output, which is f of fx, so exponential sequence. So sometimes we also use, if this is n and this is a of n, if you want to write a sequence. Now look at this. What number multiplies here to get to, so 18 times what number is 6? And you can clearly see it's like dividing by 6 divided by 18, which is 1/3. So that's the factor. That means the next number will be, so here you multiply 1/3 and then again 1/3. See, you multiply 1/3 like this. So when you multiply 1/3 to 6, so it is 6 times 1/3, it becomes 6/3, which is 2. So this is 2. And again you multiply 1/3. So it is 2 times 1/3, which is 2/3. See, this is 2/3. And then again you multiply 1/3 and you'll see you get 2/9. Kind of a sequence you get. F of x is every time in the beginning it was 18. So you can create a exponential function also. And the 1/3 is the decay factor because there's a fraction less than 1. And this is the equation. So I want you to also take note. So 1/3. So what it means is the decay factor is 1/3, means 2/3 gone. What this means, 2/3 is gone, like 66 point, almost. So this is 2/3 is gone and 1/3 retains. It's like if you have a round and I break this into 3 parts like that. So this 2 pieces are gone. See, so this piece stays 1/3. So that's what it means. Each time a 2/3 is gone, and 33.3%, which is 1/3 is almost like is 33%. Okay, so let's do the last one. Okay, so